Good morning, children. This is Dr. Sekhar Chandra. Welcome to CEI. Today I'll teach water, that is hard water and soft water. What I have already started the last class, that will be continued. Last class I discussed about the removal of hardness, that is temporary separately and permanent separately. Now I'll teach how you remove both of the hardness together, that is removal of both temporary and permanent hardness. The removal of temporary and permanent hardness is called softening of water. Now softening of water I will teach today. There are 2 or 3 methods I will teach. The first method is soda lime, second method permutit, and third method I'll apply, that is ion exchange resin method. 3 methods today I'll teach one by one, by which we can remove both hardness together, not separately, both hardness. The first method is soda lime process. Soda lime process means by applying soda and lime together to the hard water. I have already taught that temporary hardness can be removed by applying lime, and permanent hardness can be removed by applying soda. Now when both chemicals together, that is soda and lime, are mixed and then applied to the hard water, then total hardness can be removed, because lime will remove temporary hardness and soda will remove permanent hardness. So same reactions I will write as last class I have written. Calcium bicarbonate, temporary hardness by applying lime, calcium hydroxide, we will get calcium carbonate plus water, that is temporary hardness. This is temporary hardness, and calcium chloride, washing soda, will get calcium carbonate plus twice NaCl, and magnesium sulfate plus sodium carbonate, we get magnesium carbonate plus sodium sulfate plus sodium sulfate. So this is, both of them will remove what? Permanent hardness. This is permanent hardness. Both by applying sodium carbonate we remove permanent hardness, and by applying slaked lime we remove temporary hardness. So by applying or by using soda and lime we remove both the hardness together. This is the first method called soda lime process. Alright. Now second method is called permutit process. Second method called permutit process. Second method called permutit process. What is that? Permutit is an artificially prepared zeolite. Zeolite is a natural product, and artificially zeolite is called permutit. And this permutit can be represented by the sodium permutit. Na2P, P stands for permutit. What is that? It is artificially prepared zeolite. Zeolite, this is Na2, Al2, SiO4 whole twice, X water. This is zeolite. An artificial prepared zeolite is called sodium permanganate, which can be represented by the formula Na2P. Now, sodium permanganate when applied to hard water, sodium permanganate can remove both hardness together. Because sodium permanganate reacts with calcium, they form calcium permanganate and sodium ion will be released. Similarly, sulfate and bicarbonates. All kinds of ions which are responsible for the hardness, that will be removed by permanganate, by sodium permanganate. So, by applying sodium permanganate, we can remove both hardness together, that is temporary and permanent, and what are the reactions taking place behind it, that I am showing by writing. Now, sodium permanganate Na2P, sodium permanganate plus magnesium sulfate, suppose magnesium sulfate, then they prepared magnesium permanganate plus Na2SO4 or sodium permanganate plus calcium chloride, calcium permanganate plus twice NaCl. Now you see that all permanganate, calcium permanganate, magnesium permanganate and calcium permanganate, they are deposited and separated. So these ions are not present, the soluble ions, soluble salts are removed as insoluble permanganate. So we can remove these soluble ions which are responsible for the hardness of water, can be removed by applying sodium permanganate. Let me conclude that sodium permanganate is another chemicals which can remove both hardness together, because sodium permanganate remove soluble calcium and magnesium bicarbonate as calcium permanganate and magnesium permanganate. Similarly, sodium permanganate remove soluble calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate as calcium on magnesium permanganate as a precipitate. So those ions are removed from the hard water and it becomes soft. So this is the second method, which is called permanganate process. Permanganate process is the method by which total hardness can be removed by applying sodium permanganate, and sodium permanganate is nothing but a artificially prepared zeolite. A zeolite formula I have already shown you. So you understand the second method. And third method, that is third method is ion exchange method. Ion exchange method. Third method is ion exchange method. Now, ion exchange method, what is that? Now, ion exchange method is a method by which we can remove both soluble cation as well as anion. Now, there are two types of ion exchange method. Ion exchange method, we apply ion exchange resin. What is that? Ion exchange resin are two types: cation exchange resin and anion exchange resin. Okay, cation exchange resin, cation exchange resin can be represented by RSO3Na. This is called cation exchange resin. Now cation exchange resin will remove the cations from the hard water. Cation exchange resin will remove the cations from the hard water. How? We can show the reaction Na plus calcium, then we will get this is deposited as RSO3. What is R? R is called alkyl group. Alkyl group means methyl, ethyl, etc. And what is SO3? SO3Na. SO3Na, this is called sodium sulfonate. SO3Na is sulfonate group. Sulfonate group, and this is Na is sodium sulfonate group. So R is the alkyl group like methyl, ethyl, etc. SO3Na is another group, another radical that is called sodium sulfonate, SO3Na. Now this sulfonate group, RSO3Na, when combines with the calcium ion, this calcium ion, soluble calcium ion, will be deposited as RSO3 whole twice Ca, calcium alkyl sulfonate, as a precipitate deposited, and sodium ion will be released. Okay. Similarly, magnesium ion, we can use RSO3Na plus magnesium ion, we can get RSO3 magnesium, and again sodium will be released. So sodium ion doesn't have any contribution towards the hardness of water, and this magnesium ion will be soluble. Magnesium ion will be deposited as magnesium alkyl sulfonate deposition. So we can remove cation by applying cation exchange resin, which can be represented by RSO3Na. Now, how you remove anion? There we can apply anion exchange resin by anion exchange resin, and this anion exchange resin function, the function of the anion exchange resin to remove the anions from the hard water. Now anion exchange resin function to remove the hardness, that is anion which are responsible for hardness of water. And anion exchange resin can be represented as R4NOH. R4NOH, R means alkyl radical, I am already told. Alkyl radical, that is methyl, ethyl, etc. And NOH group, this is called oxime. This is called oxime. Anion exchange resin can be represented by the formula R4NOH, where R, there are 4 R are there, and each R called alkyl radical or alkyl group, example methyl, ethyl, etc., propyl, etc., and NOH, which is called oxime. This is another functional group called oxime. Now, by applying anion exchange resin, we can remove anion, soluble anion from the hard water. And how will they remove? I'll show it with the help of chemical reactions, that is R4NOH plus bicarbonate, we get R4NOH plus chloride, we can get R4NCl plus OH ion, R4NOH plus sulfate, we get R4N whole twice SO4 plus 2 OH ion. Now you see that soluble bicarbonate, soluble chloride and sulfate ion, those ions which are soluble state in hard water are removed as insoluble substances or insoluble deposits, because R4NH3 is deposited, that means bicarbonate deposited as this compound, chloride is deposited as R4NCl, and SO4 2 minus or SO4 sulfate deposited as R4N whole twice SO4. That means that all soluble ions are removed in this way by combining with the anion exchange resin. Okay, anion exchange resin. So let me conclude that ion exchange resin method is a very popular method what we are applying nowadays everywhere. There are two types of ion exchange resins. One is cation exchange resin and anion exchange resin. Cation exchange resin function is to remove the cations from the hard water. Anion exchange resin function is to remove the anion from the hard water. Okay. So conclusion is that there are three methods I applied, or three methods I have discussed or taught today. That one that is soda lime process, second overbottle process, and third ion exchange resin method. In this way we can remove both the hardness together, and that is called softening of water. Okay, then hard water and soft water we have finished today. Next class we will discuss about the questions, different questions related with this chapter. So let me complete today my teaching. So thank you everybody. If you like this video, please do like, share and subscribe. Thank you.